Reorder level is a technique that gives us a good idea of when we've hit the reorder point. Once the reorder level we've calculated has been reached, we have to call our suppliers and place a new order. In this lesson, we'll cover another technique which is useful for inventory management purposes. It helps us calculate the optimal level of inventory we should request with each purchase order. This technique is called economic order quantity and is one of the most frequently used methods in optimizing inventory. EOQ, as it is frequently referred to, is based on mathematical calculus and helps us determine the minimum cost we'll sustain given that we already know a few variables. These variables are the expected annual usage of the product we are purchasing, how much of the raw material we expect to use in a given year, price, how much a unit of this product costs, including delivery costs, cost of purchasing in terms of paperwork, follow-up, and inspection. Remember, all these activities require manpower and manpower costs. And finally, we have holding costs. Once we buy the product, we have to place it in our warehouse. Storage can be quite costly in urban areas, as we've mentioned. Moreover, this is where we take into account costs related to obsolescence and the risk of robbery, and costs related to blocking our money for a given period of time. All of these variables give us a more complete idea of how much does it cost to order inventory. Not only do we spend a significant amount to finance the inventory, but we also have to sustain all these other costs related to keeping the inventory in our warehouse. So, mathematical calculus allows us to obtain a formula, the Wilson EOQ formula, which has been used for more than 100 years actually. The Wilson EOQ formula can be written in the following way. The square root of 2 times the annual usage of the raw material times cost to purchase divided by holding cost. Imagine we have the following example. A firm uses 4,000 units of raw material annually. The cost per unit of this raw material is $3. The standard holding cost applied in many industries is 3%. So we'll have 3% times the product's price, which gives us 9 cents. When we substitute these numbers into the formula, we obtain square root of 2 times 4,000 multiplied by the cost of purchasing $3 divided by 9 cents, which is our holding cost. And the actual result we obtained from this calculation is 516.4. Let's say 517 units. We have to order 517 units at a time to minimize our inventory costs in this situation. Of course, the EOQ formula has several drawbacks. It assumes that the lead time for vendors is constant. It is built for constant raw material prices. It doesn't take into account large volume discounts, and ordering costs do not change. Nevertheless, it is an easy-to-understand and elegant tool that allows us to have a better idea of the type of techniques used to optimize inventory spending. Of course, nowadays, companies incorporate formulas like this within their ERP systems, and a large portion of the work is automated. However, the challenging part of using EOQ is to estimate actual holding and purchasing costs. There is much more to this model than simply applying the formula you see here. Each of the variables needs to be estimated carefully. Otherwise, the result, which the formula gives us, wouldn't be an optimal solution.